Okay, parallels and perpendiculars, we're going to do a little bit with slope. Okay. Parallel lines. I'd say in general you probably know what parallel lines are. But we need to compare it and the definition to another term that's in today's lesson. Parallel lines are two lines in the same plane that do not intersect. Two lines in the same plane that do not intersect. There's a symbol that we use for parallel, and it's two straight up and down segments. And in a diagram, like if there's a picture and I want to show in the picture that there's parallel lines, this blue arrow, could be any color you want, but that arrow that's on the line rather than at the end of it, that indicates parallel. And it could be that that drawing doesn't have a triangle kind of arrow. We could just have your two lines and then an extra arrow. I guess I kind of do the triangle usually. Now that I drew it, I thought, oh, that is the way I do it. But you could have just an extra arrow or a double arrow. So what do the arrows at the end of the line mean? The line goes on forever. So the arrow that is more on the middle part of the line is the parallel marking. So what do I have a picture of? Train tracks.
They never cross.
Okay, they never cross. They're in the same plane, so those would be parallel. Technically, when it curves, that's not going to be parallel. But there are certain sections of railroad tracks that we can use as an example of parallel lines. Okay, done with the notes. So if I had this diagram, I'll just finish while some are working on notes. If this is point A and this is point B, this is C and this is D, to use the symbol related to this diagram, I would say line AB is parallel to line CD. That's how you would use that symbol. Perpendicular. Perpendicular are two lines that intersect to form a right angle. So the definition, two lines that intersect to form a right angle. The symbol for perpendicular is like an upside down capital T. I don't know if you can find that in any of your fonts. To show you if you have to write that in. And in a diagram, the perpendicular, you're going to have two lines that intersect. And to indicate that this is a right angle, we often use like a square corner marking. That marking means perpendicular, which now we know means that there's a right angle where those two lines intersect. So not only do they cross, but they cross at a certain angle. That's what perpendicular would be. Now the tree picture is there because usually when we're measuring a height, we have to interpret that as a perpendicular to the ground. So that tree is perpendicular to the ground. Are all trees perpendicular to the ground? I'd say probably not. You know, some trees that slant. But there's an example of perpendicular. So if I put points on this again to show you how to use that symbol. For this diagram then we would say line AC is perpendicular to line DB. intersects and forms a 90-degree angle. And then a term that's probably not as familiar, skew. S-K-E-W. Skew lines are two lines that do not lie in the same plane and do not intersect. Parallel lines don't intersect either. Skew lines don't intersect. So what's the difference?
One's in the same plane and another's not.
Parallel lines are in the same plane, skew lines are not. So the kind of sketches, we have to show three-dimensional when you're showing skew to get them in different planes. So my green sketch here, you can see that I have one line that's solid, so that line is in that plane. But the other line, notice how I show part of it dashed, so that means it's going through the plane. Grab some of my models here. So that sketch, here's my plane. One of the lines are right in that plane. Remember the plane, the cardboard could keep going. So in the plane, and then the other one goes through the plane. They don't meet at the same point. This could be slanted a lot of different ways. Those two dowels do not touch, they don't intersect, but they're not both on the same flat surface. One's on it, one goes through it. So that would be skew. Got to be careful that you don't draw it so that they touch. That's not skew. They have to not touch. All right, I think the next is come up with some examples. Okay. In the room here, some edges. Skew, or parallel, or perpendicular. All right, how about looking up the front here, this top brown edge and the side of the board. That would be an example of perpendicular. Parallel would be the top brown edge and this shelf markers. That would be parallel. What would be skewed to this brown edge? Doesn't intersect it, but also okay, so maybe this edge on the doorway, this edge is skewed to that brown one. They're not in the same plane, but they still don't intersect. They're not parallel. What else would be skewed to that? The bottom what? The bottom of the smart board. Okay, that's going at a little bit different angle than what that brown edge is. Correct. See, I think I had some skiers showing here. You see what that is? What relationship is that trying to show? Parallel. Correct. Perpendicular, got them crossing.
Skew.
Skew, correct. They're going different directions, not touching. It kind of looks like maybe there's some, but yeah, skew. I'm looking at the word skis. Should skis have another I in it?
No.
That just looked weird to me. Maybe I thought maybe I spelled it wrong. All right, we did a few room examples. What would be some others? Pick out some more perpendiculars. Let's go perpendicular.
The wall and the floor.
Okay, so since we're doing lines right now, maybe an edge on the wall. Let's see, why don't we go lines instead of planes? I think you named planes for me. Okay, the cracks between the bricks. An edge going this way and an edge going up and down, make a 90-degree angle. Maybe you can see them better on the side or the back. Okay, what else is perpendicular in our room here? What lines? part of the top there. The planes, are talking about this. Okay, so this edge and maybe the one going up and down, that would be perpendicular. Okay, when I look up, there's all kinds of perpendiculars on the ceiling. I think the dividers between those tiles. How about parallel?
Both sides of the lights.
Okay, so two long sides of the lights, or the two short sides of the lights, kind of feel like I'm directing an airplane. What else is parallel? Those two, top and bottom,
It's not both top and bottom sides.
correct?
The sides on the square.
The sides on the square. Oh, on the model there, a couple of the green edges going the same direction. Oh, the brown one? Like edges that are going up and down are all parallel. There are some parallel, there are some perpendicular, there's even some skew on that. All right, how about skew again? If we had that model, and I'm not gonna take it down, but let's grab another box here. This can work, doesn't it? Okay, what edges on here are skew? You want one this way? Okay, so this one, and then she said the one going up and down. So that one going up and down, and one going across this way. Like here. Okay, this one and the bottom one here. Actually, those are parallel. They're going basically the same direction. Would you agree on that? Okay, but where's the plane? They have to be coplanar if they're parallel. Yeah, they're like diagonal. They're kind of tricky on those. So skew, you want them going different directions. Maybe where my pin is and then coming forward and backwards down here. Not up here because they would intersect. So you want them not to intersect, but also go different directions, I guess, to be skew. Okay, then we have planes that are parallel. Alan was giving me some planes just a little bit ago. For planes to be parallel, we need two planes that do not intersect. Like in the room, the ceiling and the floor. Two planes that do not intersect. My ceiling technically stops somewhere. My floor stops somewhere. We could think about it continuing to the next classroom and the next one after that, but eventually it would stop. But planes, if we think about the floor as being the ground of the earth, I guess it goes quite a ways. So anyway, think about your planes continuing. So I think we talked about this diagram earlier. Maybe it's regular basic. But the sketch on the left is kind of hard to tell if that's two planes side by side or one higher or lower. If it's two planes side by side, if they're the same height side by side, they really are parallel. So like the ceiling in this room and the ceiling in Mr. Brazy's room, they really are on the same plane. They're not really parallel. So that first sketch is kind of hard to interpret. The second one on the right is a better sketch because with the dashing in there, you can tell which is higher, which is lower. So that's probably a better picture to show parallel planes. All right, how about perpendicular? This describes a line perpendicular to a plane. A line perpendicular to a plane. It says a line intersecting a plane in a point that is perpendicular to every line in the plane that intersects it. Again, demo what that's talking about. So the plane, or the line has to go through the plane. And it has to be perpendicular to every line in the plane that intersects it. So if I draw a line on my cardboard, it has to make a 90-degree angle with the dowel that's going through. Making a 90-degree angle this way. Making a 90-degree angle going back. Making a 90-degree angle on this side. So in other words, every direction it needs to be making a 90-degree angle. If I tip it this way, from one angle you can tell it's not making a 90-degree angle. From another angle, I don't know, maybe it's not so obvious that that's not 90. So it has to be making a 90-degree angle from every side in order to be perpendicular to the plane. See if you can make that sketch. I have a couple 90s marked there. The dashing for the line going through the plane. So think of a flagpole. Flagpole has to be perpendicular every side of it. Otherwise it might be tipped a little bit. No longer perpendicular to the plane. The tree that we were talking about, you could have a tree that's nice and perpendicular, or you could have a tree that is slanted. So to be perpendicular to the plane, it has to measure 90 degrees on every side. So I'm trying to draw the picture. Make sure you put the 90 if you're drawing that picture. You need to have the 90s, actually more than 190. Are you able to dash that? Anyone still need the screen? No? All right, we're going to do a couple constructions, so I guess we need our tools. So how about last person in each row? Come up here and get enough tools for people in your row and hand them out when you are getting back. We're going to go without a protractor and end up with a 90-degree angle. So in your notes, put the title, write that you're going to construct a line perpendicular to a given line through a specific point. So that if I put that on your notebook check, you would know which one to find. And we will start with a line. And there's a point above it. The construction makes a 90-degree angle from P to that line. So we're going to get this to be 90 degrees. All right, ready to construct? Okay, the first step is put the point of the compass on P. Open your compass wide enough so that you can draw a line, or excuse me, an arc that crosses your line twice. How big did you get on your picture? Now you will use those two intersection points to make an X. So you're going to use where it crossed here and where it crossed here. And I still have the same compass setting. You could change it right now if you wanted to. But I'm going to go from that intersection point, make an arc. I'm going to the side opposite of where point P is. Because if I go back up, I'm just going to find point P again. So I want to find a second point. Make an arc from that intersection and from the other intersection, the same arc. With your straight edge, connect this crossing point and point P. That'll make a line, it should measure a 90-degree angle. Right through there. It should make a 90-degree angle and it should go right through point P. For a second time to practice that, let's have you tip it a little bit.
You get it?
And put a point P. Do the same two steps, trying to make a 90-degree angle with point P. That's the two that I need to look at.
The same.
For the point of the lens. It could be below it, yes. Maybe that's what you want to do the second time you start with below.
Okay. Okay.
Make an arc that crosses the line twice.
See, sometimes when you, like, if you're using this and you're moving this part of your pencil, yeah. So I usually just try to go hold it on top of it. Or like hold this part down. Okay. Okay. So you got your P, okay. This is where it crossed, right? This is where your compass crossed. Okay, so now you're gonna go from those points. Make an X, open it probably a little wider. You just need an X down here somewhere. Okay, now go from your other side.
That's looking good.
There you go. You had part of it.
Okay, on those, the point that we started with was not on the line. Okay, most of you are ready for the next one. The next one has the point on the line. So give yourself room to do the construction, but draw a line, and the point is going to be on the line this time. We're still going to make a 90-degree angle. But the point's in a different spot. The steps are basically the same as what we just did. The first arc is going to look more like a half circle, and you can go down if you want. With me up here, it's easier if I go up. So with the point of the compass on P, set your compass so that you can make an arc that crosses your line twice. Whether you go up or down, doesn't matter. That's to cross the line twice. Now, in order to make the X, you will have to open your compass wider. Otherwise, you'll just get back to point P. So after you do that step, open your compass wider. From those intersection locations, again, make an X. You can go up or down, or you could do both. I don't really care.
No. You're going from where you
Connect that X and your point P.
So just go down.
Your 90-degree angle on this.
Go down there. You can go either up or. Yeah, well.
That should make a 90-degree angle. Do that a
Go the other
second time, so you can do more on your own. Start with a line, tilt it a little bit or something,
There you go.
put a point on it. Maybe further point in. than your first one was. To do the X, you do have to open your compass wider. Otherwise, you won't get your two arcs across. You do this X, you go from this point, and to this point, and to have 2 points to connect. But since we started with one of the points, you just had to come up with one crossing point. If you wanted to make that arc go further down, it'll look like your midpoint construction, it can look like that. You would have 3 points then to connect instead of just 2. All right, I think that's all the constructions. Let's have you try and draw a box. You want some dot paper? Some of you might like the dot paper. Others probably can make a box without. We're going to sketch a few prisms and then do a few calculations of slope, which should be reviewed from Algebra 1. Your straight edge, you've got your packet there. Straight edge probably would help on this. That helps you visualize which one to connect. Let's try and draw the same prism box on your paper as what you see up here. Should I keep any dot paper?
Oh, here it is.
One for over there. So I need to have certain ones dashed there. All right, if you're using the dot paper, looks like from one corner I went straight up 1, 2, 3, 4, 5 spaces. And then I took the diagonal for 1, 2, 3 spaces. When I went straight across here, it's like I did 2. So once you get those kind of set up, then you just make the other things matching. You want to complete the front of the box, the bottom of it will go horizontal across those 2 and up the 5. I wanted to draw the front of the box. Maybe the diagonals is where your straight edge would help. How about draw the front rectangle? It's like if you do the spaces like I did, yours ends up skinnier. It's up to you. Maybe you want to go 2 or 4. As long as you're going the same number. Okay? So if you've got the front of the box, maybe I could go over here. 1, 2, 3, 2 this way. 5. Okay, so there was my front of the box. Now I'm going on the diagonals, 3 spaces, 3 spaces, 3 spaces. This one will be 3 spaces, but it's dashed. I went 3 spaces diagonal on each of them. Then I'm going to connect those. It's going to make another rectangle for the back. Straight across, straight down, dashing it as I go straight across, and dashing as I go straight up to make the prism. Show your neighbor. Does it look like a box? The dashing is in there to help your brain understand what's going to be. That's where maybe the dot paper helps you get the diagonals. Try one more prism. I think there's a prism on your assignment to try and draw. Let's do a triangular prism. Now this one's sitting down rather than standing up, more like a doorstop. So perhaps draw the triangle first. And I think maybe the way my paper is, if you turn it the long way instead of the tall way, like what, hot dog instead of hamburger or something like that, if you turn it the other way, maybe that's the right spacing to go with what I have up here. Okay, so let's go up and down. I think we all have room. Looks like I did 3 spaces up and 3 big spaces going left and right. Then when you go diagonal, it should hit dots. Now I'm going to do the slanted ones. I'm going to run out of room here, so I'm only going to go 2 back instead of 4. Okay, so go on the diagonal. If you have room, go 4 spaces. I don't have room to go 4. So this one's going to be dashed. Then when you connect those slanted edges, you should make the triangle that is the back of the box. The up, down is dashed. The left, right is dashed, and those are some big spaces. And along the diagonal, should finish it. Mine looks skinnier than what there because I ran out of room. Gotta have a triangle for the back. So now here, go across. Up. Not up there, straight up to this one. Just like that one. I've got some artists in the room. Alright, so there's a little prism drawing. And then let's just do a little bit of slope to finish up today. Calculating slope. And in algebra 1, we did slope. That's a slope formula. That's not the slope formula. That's slope intercept form for a line. Yeah, the third formula down is the slope formula. Okay, so everybody cut up. I skipped a few drawings. Let's do slope. So here's some notes on slope, and we'll just do a couple sample calculations to refresh your memory. I'll teach you to calculate on your homework. You'll get like 15 minutes, 10 to 15 minutes to work on this segment here in a little bit. Depends how long it takes you to write down the notes. The slope of a line, slope indicates the slantedness of a line. How slanted is it? And it also indicates whether it slants up or slants down, depending if it's positive or negative. And I don't know if you want the whole sentence on a graph or just the formula at the end. On a graph, slope can be found by counting the rise and the run from one point on the line to another point. So maybe to summarize that second sentence, slope is rise over run. Then by calculating our formula, you subtract the y values and subtract the x values in the same order to get slope. So if you have what I've circled, that would be the major parts of that screen. I'm not going to give you the graph of it. We're going to practice a couple of formula calculations. So the bottom formula is the one we're going to use on our practice and our assignment. So help me pick 2 points. Sydney, give me a point, an x and a y. Positives, negatives, whatever.
-2, 7.
Okay, -2, 7 is 1 point. And Tim, what's another one?
-3, 10.
Okay, there are your 2 points. Let's find the slope of the line that would connect them. Using the bottom formula where you're subtracting the y's and the x's. Remember, your points are an x and a y. I'll call these x1, y1 because they're the x and the y from the first point. And we'll call this x2, y2 because it's the x and the y from the second point. Those are subscripts, not x1s. So what minus what? 10 minus 7 over. Correct. So watch your positives and negatives. 10 minus 7? 3. Over. -1. What does 3 over -1 simplify to be? -3. Would this line be going up to the right or down to the right? Down as it goes to the right. From your graphing, you go down 3 to the right 1, down 3 to the right 1. Okay, let's make one more sample and then we'll work on homework. Okay, who wants to come up with a point for me? 5, 6 is 1 point. And 7, 14 was the other one? Okay, there's your 2 points. They kept them positive. Find the slope if we would connect those 2 points. I'll have you show me on your marker board. As soon as I okay you, then we can work on the assignments along right up here. No, I don't think you need tools for homework. Homework. Correct. Few more to show?
Y2 minus Y1. No, you're doing X's. Y's are on top. Y2 minus Y1. Y1 over X2 minus Y or X1. There you go. Oh, because it's 14.
Yeah.
There you go. Yep, so now we do. Yep. How many times is 2 going to go to 8? There you go.
I don't think you need the tools for the homework. Who else do I still need to check on Jack? okay? All right, watch for the ones where there's a 0, either in the top or the bottom. I'm gonna see if you remember what's what. I think you come up with those maybe on your assignment. Okay, work on your assignment for the last 10 minutes.